During the resting membrane potential, the neuron is at rest. This means that the neuron is neither sending nor receiving signals to other cells. The external boundary surrounding the cell is called the plasma membrane. Diving into a closer look, the cell membrane is dividing the outside of the cell from the inside of the cell. On the outside of the cell, it is more positively charged. The outside consists of larger positively charged sodium ions. It also consists of smaller negatively charged chloride ions. On the inside of the cell, it is more negative. Although it consists of smaller positively charged potassium ions, it also consists of large negatively charged proteins. When the membrane is at rest, during resting membrane potential, it is considered to be polarized. This is because it is more positive on the outside of the cell than it is in the inside. Within the cell membrane, there are channels. These channels are used to transport ions through the cell membrane. The ions move from inside of the cell through the channels to the outside of the cell, or vice versa. There are some channels that are always open, and other channels that are only open when a specific signal is sent through the neuron.
Resting membrane potential is changed by activating sodium channels. Sodium moves inside the cell, causing it to be more positive, making the cell depolarize, which means the membrane potential gets smaller as ions quickly begin to equalize concentration gradients. When more sodium enters the cell body gets positive enough that it can trigger the voltage-gated sodium channels found in the axon. Once the threshold is reached, all or none law applies and action potential is triggered. The sodium channels start to close. Potassium channels start to open up. More potassium moves outside the cell, causing repolarization, which returns the cell to a negative value just after the depolarization phase. The action potential ends. Sodium and potassium pumps are restored. The cell returns back to its resting state. During this whole process, the cell undergoes phase 1, resting state, phase 2, stimulation, phase 3, depolarization, phase 4, repolarization and hyperpolarization, and finally, phase 5, returns back to resting state.
Action potential occurs and the change of charge or the electricity travels down the neuron. It reaches the axon terminals. It then reaches the synapse. The synapse is the space between the axon terminal and its attachment to either a muscle, gland, organ, or another neuron.